Hello all. In this video, we're going to take a look at the structured data that we use with algorithms like decision trees. We're going to talk a little bit about how it is typically structured and the terminology that we use for it. So there's multiple pieces of terminology that kind of come from the different disciplines that come together here. So sometimes we use terms that represent the sort of statistical view, other times we use more AI type terms or spreadsheet terms. It's just kind of all gets confusing. So I want to talk through the various different pieces of terminology before we jump into learning more about machine learning algorithms themselves. All right, so we're looking at traditional machine learning right now, and so we're about to start talking about decision trees. But for decision trees and most of these other algorithms that we're looking at, support vector machines, k-nearest neighbor, the boosting and bagging algorithms, ensemble learning, all of these kinds of things are very similar. They assume that the data is in the form of a table or a spreadsheet, and the values may be numeric or they could be ordinal or nominal values. Some algorithms will require that we convert everything to numeric data. So if you have nominal values, they just renumber, assign a number to each one in no particular order. If you have ordinal values, you might want to be careful in the ordering that you use to assign numbers to them. Some algorithms can work with a mixture of text data that is nominal or ordinal, or perhaps numeric data as well. Okay, this is a visualization of a typical layout. So what you imagine that you have is each row of your spreadsheet represents an example. This is a single example that you want to learn from. It has a fixed number of attributes. Those are represented in the columns, and usually either as the very first or the very last row in the columns, or last column, is a special column for the target that you want to learn. That could be, I'm using categorization because classification is going to be our go-to examples, but if you're doing regression, it would be a number. It could even be multiple numbers or multiple categories, depending on the problem that you're looking at. So this is not hard to do with a spreadsheet. I mean, occasionally you'll run into a spreadsheet where they've flip-flopped rows and columns, and that can be dealt with. But generally speaking, this is our assumption. Sometimes this data has no header row, or it has a header row that provides the names for the categories. Either is okay, but you have to know which you have when you're working with the data. All right, so down here at the bottom, I have some terms. And this is where things get kind of crazy, because I said before, each row represents a single example. An example is one way we use this. So it's an example we want the model to learn from. It is also called an instance, or a case, or a sample. Sample being the one that comes more from statistics. It's a sample drawn from our overall world or situation. So any of these terms get used, and they get used somewhat interchangeably. So, as an example, we're going to keep looking at this really small, simple example of a good dog data set, where the idea is someone wants to adopt a dog. We've asked them what they like in a dog, what they're looking for, and things are either a good dog if they fit the person's rule, what they're looking for, or they're a bad dog if they do not. It's not a value judgment on the dogs. They're all good dogs. So if we have this example, what we would do is each row in our table would represent the attributes for a single individual dog, and then the category would be, is this something that our person is looking for? Is it not? And the attributes could be anything that makes sense to you. So it could be physical attributes, size, fur type, color. It could be personality. It could be breed, if that's relevant. There could be any number of different attributes that go along with that. All right, each column in the data set represents an attribute. We call these attributes or features kind of interchangeably. Again, there are different terms for these, and I already pulled out the terms category and target. I used both of those. Categories can be binary. So in the case of like the good dog example I was talking about, a dog is either a good match or not a good match for what someone is looking for. That's a binary situation. Or you could have multiple categories. So maybe I'm um, categorizing. I'm trying to think of what something you do. I have pictures of animals and I want to categorize them into mammals, reptiles, fish, birds. So I have 4 categories. Either is fine. There just changes some things slightly about how you think about the examples. And the classification task, as we've talked about before, is the main one we're going to look at. It's where we have categories that we're trying to learn. There are different algorithms for regression. We're going to focus on classification given the time that we have. All right, so that's just a quick overview of some of the terminology and how we're going to think about the data. And then we're going to jump right into the algorithms and just have this in the back of your head. This is an assumption that we have that we'll keep using over and over. I will see you very soon.